Hi again. This is the last page of the Unit 5 practice test. It's page 28, but on the bottom of your paper it says page 26. These are the solutions and guided notes for solving exponential and logarithmic equations. I should tell you ahead of time that number 12 would be an Aspire level question, maybe a bonus or reach on. So to solve a question like number 11, since you can't get a common base out of 5 and 3, you need to be able to log both sides. So the exponent gets swung down in front. That becomes 2x plus 3 times the log of 5. And you set that equal to x minus 1 times the log of 3. Now the log of 5 and the log of 3 are just numbers that your calculator can figure out for you. So you can divide both sides by log 5 or log 3 and then continue the problem from there. So you've got 2x plus 3 equals x minus 1 times the log of 3 divided by the log of 5. Again, that's just a number. And then you can just do algebra by adding or subtracting, subtracting 3 from both sides, bringing the x together and combining like terms and getting your solution. So that is the beginning of the solution for that problem. For number 12, this is the tricky one, right? This involves a substitution problem or substitution technique, and I'm going to let I'm going to let 2x equal y. Watch. If I let 2x equal y, then this becomes e to the 2x. You see how that would be to the 2 plus 5e to the 2x minus 24 equals 0. Well, now if I let 2x equal e to the 2x equal y, then what happens is I have now y squared, e to the 2x squared, right? I'm just doing that substitution of e to the 2x for y, plus 5y minus 24 equals 0. Now this is a factor situation where I'm looking for two numbers whose product is negative 24 and whose sum is 5, and the signs are going to be different, and I believe that would be plus 8 minus 3. So I've got y equals negative 8, y equals 3, but remember that was e to the 2x equals negative 8, and e to the 2x equals 3. Now I can natural log both sides and make the one on the left say 2x ln e equals ln negative 8. And I'm pausing because I'm stuck here on the natural log of negative 8. There is no solution for this one. That would be an extraneous solution. Here, because I can't take any number, I can't take e, raise it to a number, and get negative 8. But I can have a solution for this other problem, the other part of this problem, which is 2x ln e equals ln 3. ln e, that just becomes 1, so I've got 2x equals the natural log of 3, which is just a value. So x is going to equal the natural log of 3 over 2. Again, this is an Aspire 2 level question, a reach for calculus, and not something that we've practiced, but something that you could certainly strive to do, and if you got it, great, good for you. Okay, in number 3, solve and be sure to reject any value that is not in the domain of the original logarithmic expression. I would like the exact answer, and where necessary, use a calculator to obtain a decimal approximation, and let's go out to 4 places if necessary. So here I'm asking you 3 to the 4 equals x. We start off pretty easy, being able to go back and forth between exponential and logarithmic functions. 3 to the 4th, that's 81, is equal to x. Now here I've got 4 cubed equals x plus 5. So 81 is going to be some number plus 5, and that number is going to be 76. In this one, now I've got 4 cubed should be equal to 3x plus 2. That's 4 to the third. Oh, sorry. Whoops. With this one, 4 to the third is not actually 81. Let's go back over that. 4 to the third is 64. So that should say 64 equals x plus 5, and x should equal 59. Now for this one, 4 to the third, number 15, equals 3x plus 2. So that is 4 times 4 times 4. Again, 64 equals 3x plus 2. Subtract 2 from both sides, and 62 is equal to 3x. Divide both sides by 3, and whatever 62 divided by 3 is, that is your answer for this question. Now, I'm looking at a natural log problem, but have no fear. I'm going to subtract 6 from both sides, and I'm going to get 2 times the natural log of x equals negative 1. I'm going to divide by 2 and divide by 2 and get natural log of x equals negative 1/2. Now, if you reach for your calculator or you try to figure out, okay, I've got ln x equals negative 1/2, there's an e right there. So e, what this is asking me is e to the negative 1/2 equals x. And when you raise e to the negative 1/2, whatever number you get, that's the answer for x. Okay, in 17 and 18, I am condensing logarithms. So I am looking at log base 5 of x times 4x minus 1, and setting that equal to 1. So on the I've got log base 5 of 4x squared minus x as a quantity equals 1. So now 5 to the 1 is equal to 4x squared minus x. So it looks to me like 4x squared minus x minus 5 equals 0. If we factor that, we're looking for a product of 20, negative 20, and a sum of negative 1. I believe that those numbers would be, and we're going to factor by grouping, or we're going to factor by borrow and pay back. I'm going to do factor by grouping here. So I've got 4x squared minus 5x plus 4x minus 5 equals 0. Factor out an x here, and I get 4x minus 5. Factor out a 1 here, and I get 4x minus 5 equals 0. Set each of those equal to 0, and x equals 1, sorry, negative 1, and x would equal 5/4. Take a look at these answers. Though they're algebraically correct, they don't work in the context of the problem because I cannot have a negative result. When I raise 5 to something, I cannot get negative 1. So this is an extraneous solution. But x equals 5/4 does, in fact, work in the context of this problem. Okay, number 18. Now I'm condensing logarithms and then solving. So I've got log base 2 of x plus 2 divided by x minus 5 as a quantity equals 3. So what this is saying is 2 cubed equals x plus 2 over x minus 5. So I've got that 8 is equal to x plus 2 over x minus 5. So 8x minus 40 equals x plus 2. And then you're on your way with the algebra. Looks like 7x should equal 42, and x should equal 6. Now, as always, double check my answers, but I think that that's where we end up. All right, thank you all very much.